Alright guys, this is Dr. Pennington again, and in this video I'd like to talk to you about possibly the most important concentration term you'll use in chemistry, both in 1211 and 1212 and organic and all the other chemistry classes that you take. In fact, you'll even see this concept, even if you've seen it already. You might have seen it already in your biology class, the concept of molarity. Like I said, it's the most important concentration term to learn, and you'll use it so many times and so often, it'll be the bane of your existence if you don't understand it as early as possible. So let's make a goal to understand it right now, so when it comes to it later on, you've got it and it's one less thing to worry about. Simply put, molarity, which has the symbol big M, has very particular units, as do all the concentration terms that you guys are going to see in chemistry. In this case, the concentration, or the molarity, is represented by the number of moles of the solute. The solute is the species you dissolve into the solvent, and in most cases, at least in 1211, the solvent is water. Alright. And so, like I said, you have the moles of solute, and then you have the liters of solution. And it's important to stress that this is solution. It doesn't say solvent, it doesn't say anything else, it says solution. So in order to calculate the molarity of any solution, you need two things. You need the moles of your solute and the volume of your solution in liters. So I have two examples here. One's more simple than the other, but we'll do the simple one first. So the question reads, if 0.35 moles of sodium chloride is dissolved in enough water, notice it doesn't say an amount here, it just says enough water to make a solution with a volume of 750 mils, what's the molarity of the solution? So the one thing you should be able to understand is, I can't figure out a volume of my solvent because the question doesn't tell me. But it does tell me a volume of the solution. So a solution with a volume of this. So that's my solution volume. So all you're going to do here then, if you want to figure out your molarity, it's really very simple, and most of you will have figured it out already. You take the moles of the solute, which in this case we're already given, 0.35 moles, in this case of NaCl, all divided by the volume of the solution in liters. So you can't put 750 mils on the bottom here, it's got to be in liters. And I'm sure you guys will remember how many milliliters are in a liter. It's 1,000. So therefore in 750 mils we have 0.75 liters. So therefore 0.75 liters goes on the bottom, giving us a molarity of 0.47 moles per liter. Some people will also write, and you may see instructors do this, say 0.47 m, because m is the same thing as moles per liter. Alright, so big M equals molarity, which has units of moles per liter. So either of these two answers is fine. Alright, so that's the first one done. Let's switch colors for the second one. This one's a little bit more involved, because in this case we don't start with moles of our solute, we start with grams of the solute. So let's just read the question and check we can understand what is happening. If 25.7 grams of aluminium chloride are dissolved in enough water to make a solution with a volume of 875 mils, what's the solution's molarity? Well, it's asking exactly the same thing as the last question was. The only difference is you've got to do something with this grams, because obviously grams is not moles. You guys have seen before, particularly in my last two videos, about how to convert from grams to moles. The volume is already in milliliters, just as it was here, so we've got to do a quick conversion into liters. But let's do the hard part first. We know we want to convert this 25.7 grams of aluminium chloride into moles. And so we know if we have 1 mole of aluminium chloride, we just need the molecular weight. So we add together 3 chlorines. Chlorine is 35.45, aluminium is 26.98, and that gives us a molecular weight of 133.33 grams of aluminium chloride. In case you're wondering, aluminium is what I call the thing that you guys call aluminum. Just in case you're wondering. Alright, well, why is he talking that weird way? That's just British. Alright, so then when we divide these, we get 0.193 moles of aluminium chloride. Notice this is not our final answer though, because we haven't taken into account the volume. And just as we did in the last question, we can convert that volume into litres very easily. If 750 mils was 0.75 litres, then 875 mils is 0.875 litres. So therefore, to figure out the molarity, it's not, as you can see, a huge challenge. Once we got to this point, 0.193 moles of aluminium chloride divided by 0.875 litres gives us a concentration or a molarity of 0.220 moles per litre, or if you prefer 0.220 capital M. Again, those both mean the same thing. Alright, so that's little basics about what molarity is and how you can calculate it. Alright, thank you.